Okay, then it's going to be this valve control and the HMI and see how it works in a runtime. And kind of trying to relate it to the kind of elements that existed in the definition. So I have to try to switch a little bit between this and see how that works. Yeah, we can probably see it here. So I've started the simulation. It's running. And now I have to simulate the HMI panel because I don't have a panel. This simulation would work with a real PLC too, provided that the IP address is mapped and stuff like that. But the simulation is here. Again, some other videos have shown this too. And it compiles a little. So what I did was I just didn't save the project. I just reloaded it. So here is the simulation. We could probably have it a little smaller. That's probably the best I can do. So it's the valve I have to control. Yes, noted. So this is what it looks like. So now it's in automatic mode. So that was let's say the rectangle in the back here that turned green. And it's that has the low feedback, which was the let's see if it's possible to have this side by side. If we hide these and these, probably going to be okay. Yeah, you have to just queue past this stuff. Now we have it. So this one, that was that one that was visible if I had the low feedback. The low feedback is here on the simulator. And it's green here, which means that it's also confirmed low, that they have the feedback and the program has controlled it to low. And here was the graphic list, and now it's open. The valve is closed. It is open and it's green. So now the valve is closed, and then it's selected this symbol here. In automatic mode, I can't do anything to it here. Normally, when I push this button, it is possible to make for panel 2, but all HMI, they are made so that if you push this here, you have to confirm that you really want to open it. We have this closed feedback too that was down, that was confirmed, was the circle that closed, the feedback itself was down here. So the text changed color. So now it's selected this, and the background is gray, because that's the way it's supposed to look in this world when it's open. So close doesn't work. So here was a command. We didn't look at it, but the command was here for set bit for manual mode. I think that was the one we looked at. Now in manual mode, and now this one should work. Okay, it works. Here was the command out. So it's trying to opening, is pushing air in here and opening the valve, and now we have got a flow. And now you see the symbol just changed. It was flashing and stuff like that, and they have also changed this. This is just a rectangle with a fill color that's changed. Now I got open feedback. There was the states. Open was text lists. Next state is open, and it is open, and I have no faults. The faults, how they are going to look, then I have to do it a little trick here, because yeah, I can probably change these settings here. But what we are going to do now is to try to close it, and what you can do here, this one can be zoomed. So this is what we have to look at. So now its current state is open, and I want to go to close. So now it should get closed here at next state, and it should go through closing and to closed if I push this one. Closed, it's closing, and it should get to closed eventually. Okay, so that's just the way it works. I can go back to automatic, then I can control it here again, and so on. Let's see if we can simulate an error. Now we have closed, transit to high time. I think the timeout here, but I can set this one to, let's say, 3 seconds maybe. And then I should probably get an error if I try to open it. I didn't. Transit to, no, it's the simulator. So I can set that one back to 6. That was the simulator transit to high. So that was faster. So I probably have to be slower, but we can do it here. So if I say 10 seconds, now I can try to close and see if I can get a closed error. If I'm lucky. Close failed. And now we get a new one when it's made, because eventually it's going to reach the closed state. It did, so I have close failed on it. Failure closed because the simulator took 10 seconds. I think this one is 5 seconds or something for close. I've just remembered, just put it back to 6 seconds. And now to reset the 4, because it's a spontaneous failure, and now it is closed, so I can just reset it by pushing here. So to reset. And now you can see this 1 second that we looked at in the configuration of the tag. So I have this 1 second. I will put it down to 100 milliseconds to get a little more responsive. So now it should be back working like normal. What I could do too is to simulate over here. I could go and then I would need this one, and I would need to go up to my PLC. But I can do this. You can also queue past this. That was program blocks. I think I know where it is. Program main. All the programs are in the mains. Program sections. These are simulation exercise, and this number 2. And here's the instance data block. So if you double click that one, I can open it here, and I can set, as it has a PLC running down here, the simulator is running, I can set this online, I hope. Now I'm online, and then I have the glasses here. And here is the HMI that I've looked at. And here was state fault information. I can just pick a number. I think it's 4, for instance. I don't know what the number is, what the fault it is, but close fail. That was good. That was the one I had. So I can select, I don't know, number 1, feedback fault when open. Yes, here I can also operate on the commands if I want to. Because what this one does is that it sets, it writes a true to this one. I can do that. So there I erased it, and this one was set to 0. But that's what the program is doing. 4 then, that was close fail. 2 close failed. It depends upon the text I put in here. And this is equivalent to just operating here. So what this one does is reading this data and displaying them. Say the state is important here, because that decides what this one should do and the background should be. And all these confirmed high, which was this one. High feedback was a color on this one. High feedback here. Low feedback is here. That's the one that's true, so it's closed. And the high feedback, then it's open. High is open and low is closed for a valve. for motor, high would be running and low would be stopped. And here was the next state, which is this one. Where do you want to go next? And so on. So it's just a matter of animating these data here, and you can do it in a lot of ways. And you could also here have exceptions, let's say alarms, not just an information for fault, but alarms that went into an alarm list or let's say a message list. Then you can do that. You can do quite a bit with this panel too. But this is the old Siemens type panel, and now they are now HTML5 based with SVGs and JavaScript and all this crap. For the new one, but we could also in this project enter a new type panel, but then we need some runtime and do something to our PLC to open some ports and stuff like that. This one works for the purpose of just showing or illustrating how an HMI could be built. Yeah, so okay, this was just the run of the HMI configuration. See what it looks like in live, animating all these PLC data. So there's a lot of ways to animate this, but in general, like I said, red is fault. You can't use red for anything but faults. And then it is this: you have to change shape and color for animation. You can't just change color. That's not good enough. So when we looked at this valve, it's changed both shape and color for between open and closed, and then we have some flashing for animation. Normally, it's the flashing is it's flashing the state it's leaving. So when it's, let's say, opening, then it's flashing closed because that's where it was, and then it's going to reach open. But those are preferences. What you do. What's important here is red is fault, and you have to change color and shape for animation. Either one is not good enough. The shape would be better than just color, of course. Yeah, so that was a quick introduction to valve HMI. It's simple to make, but it's a lot of work, and it's a lot of work to make it look nice. That's a lot of work.